Oh, so, okay, so we're getting ready for a quiz tomorrow on rational numbers. Today is the 8th. Put that in your notes, please. Here's just a quick reminder of what a typical problem looks like. A rational function and irrational numbers are fractions, right? So a rational function has a fraction in it. And this is where the parent function would go. Right there, the asymptotes are lining up with the axes, and I really ought to have a darkened in dot here and here, though, to make this really right, because you need that point labeled or identified. Those are the two key points. Okay, you need those. All right, now is that the right graph for this blue one right here? No, because that one's been moved. Where has it been moved? Left 2 and down 4. Okay, now it's easier for me to go 1, left 2, and then down 4, but it won't be as easy when you're doing it by hand. So let me just show you what you do. Let me just kind of get this off to the side here. You remember those key points that were red there? I'm going to move them now. Left 2 and down 4. So this goes 1, 2 to the left, 1, 2 to the left, and then down 1, 2, 3, 4. And left 2 and down 1, 2, 3, 4. There's my new key points, and then I would draw a dotted line here. That's called the what? Horizontal asymptote, and then this one, vertical asymptote. And then I draw a line that gets closer and closer and never touches. Same here. And then same here, although my line was kind of messed up there, so same there. Okay, so there's my basics on how to draw the line. The domain. When I say domain, I want you to think denominator, because that'll tell us what our domain restrictions are. The domain is everything, all real numbers, except it can't be what? It can't be -2, because if it's -2 here, it would make the denominator 0, and that messes everything up. Okay, the vertical asymptotes, if I can just look at my graph, I can do it that way, but that's awfully easy. When you don't have a graph, what you look for is the vertical asymptotes are the things that they kind of come from here, and that comes from here, and so they are the V. Remember I showed you how you could kind of sort of morph the legs of the V into an X. That reminds you these are X equals, and it's anything that would make the denominator 0 unless it's a whole. Now there isn't a hole in this one, so we can just say that's the answer. But if there had been a hole at that spot, then it couldn't be a vertical asymptote, because you can't be both. We'll discuss that when we get to a harder problem. And the last one here, the horizontal, bigger on top, bigger on bottom, same on both. We're talking about the degree, bigger on the bottom. And if it's bigger on the bottom, it's y equals 0. But I really should have told you this from the very beginning. If it's bigger on the bottom, is y equals 0 plus whatever's out here. Now that's not as simple as saying Bob is a big fat 0, but it's right. And you got to add in if there's anything out there. A lot of times there isn't anything out there, but on the simple ones, on the parent functions, there is. So bigger on bottom means 0 plus whatever's here. So 0 plus -4, y equals -4. All right? Now in your notes, what I'd like you to do is take this next problem and write the problem down and answer the 4 questions about it. It is a sample problem in your notes. Okay, I'll pause while you do that. Here we go. Domain. Domain on this. Don't cross these off and then think, well, then it doesn't count in the domain. It still counts in the domain. The domain's the denominator, and that tells me there's 2 things that would mess up my denominator. X cannot be 0, and X cannot be what? 2. And the vertical asymptotes in the whole, this is kind of like my answer bank for that, right here. So those answers go in for the vertical asymptotes and the holes. Either anything that messes up my denominator is either a vertical asymptote or it's a hole. Or they could both be holes, or they could both be vertical asymptotes, but they can't be like the same thing here and the same thing here. That's not allowed. It's either an asymptote or it's a hole. Okay, so which one's which? Well, the hole is this one, the one I canceled off, and so the hole is the x equals 2 part, and therefore the vertical asymptote must be the other one. You get that? Anything that's in this list is either a vertical asymptote or it's a hole. It's one or the other. Yes, question. Good question. The whole, I like you to write it just like that. Because here's my argument with the people that write it like this, 2 comma something. Well, then that is sort of implies if I stick in 2, that I get something out. And I really don't. I don't get something out. Because that's the point of a whole, is that there's nothing there. It can't, if I put in 2, it makes my whole equation cancel to 0. And not even just 0, but undefined, because it's 0 on the bottom, and which makes this, if you were really going to make me write it as a point, I would say this. And I'd say that on every whole. Okay, so then if they made me write it as a point, that's how I'd write it. If I was writing it, I'd just write it like that. If it's 0 on the top and 0 on the bottom, you know what happens? It's still undefined. Anything that has a 0 on the bottom, period, even if there's a 0 on the top also, if there's a 0 on the bottom, it's undefined. It's like, so if you don't believe me, what you could do is test this. X plus 0 over x plus 0. If you graph that, that should be, if I put in a 0 here, then I should end up with 0 over 0, which could be thought of as 1. But since at the point 0, this should have an empty spot. So there should be a pixel missing off your graph, because it shouldn't be possible at that spot. All right, even though it's a whole, it should not be like y equals 1, yeah, but the one spot that it won't work is at x equals 0. And it's not just that it comes out to 0, it comes out undefined. All right, so let me just finish this and then I'll answer the other question that I think I have. The horizontal asymptote is the bigger on top, bigger on bottom, same on both things. Now some people ask me, do I have to do that before I cancel things or after? And the answer is it doesn't matter. Because before I cancel, this is degree 1 and this is degree 2 down here, which is bigger on the bottom. After I cancel, it comes out to 1 over x, which is still bigger on the bottom. So you see how it doesn't matter? You can do it before or after. Doesn't matter. Either way, it's bigger on the bottom. And bigger on the bottom means it's a bob. Bob starts out at 0, y equals 0. But then if there's anything over here, like plus 5 or something, you have to add that in. So it's 0 plus whatever's here is the right rule for that. Well, there's nothing there on this problem. So it's 0 plus 0, which makes it y equals 0. Raise your hand if you had those right. And that's most of the class. Good. All right, moving on. Here's a little bit harder one. Try put this one in your notes and give it a shot. I'll pause while you do that. Okay, here's this one. We start with the domain, which I want you to think d what? Denominator. And that's all things will work except you can't be 2 and you can't be -1. Otherwise, it would make a 0 in the denominator, which is undefined. The vertical asymptotes and the wholes come from this list. Which ones are which ones? Well, I can see this cancel, so that must be the whole. So it's at x equals 2 is where the whole is. No, I wouldn't try to write that as a point. I just say x equals 2. And then the other one, the vertical asymptote must be the other one, because I've already used this one up. So I'll go to this one. X equals -1. Then the horizontals. Is it bigger on bottom, bigger on top? Same on both. Same on both. And the sob ones will make you sob because they're a lot harder than the other ones. But it's really not that hard. Ratio of 1 to 1, which is y equals 1. Raise your hand if you had that one right. Good. All right. Next up. There's this kind of a problem. This one also is going to need a graph. Now, don't do the graph till the end. But this is just the same until you get to the graphing part. Okay? Try that one. So since I know that x equals 2 must be one of them, and I know it is a whole, x equals 2 is the whole because that's the thing that canceled here, then the other one, the vertical asymptote, there's nothing left. It can't be in both places, so I say none. This does not have a vertical. And if you graphed it right, you'll see it doesn't have a vertical asymptote. And the last one's the horizontal. It's bigger on top, and there are no bots, and so therefore there's no vertical asymptote. Then I got to graph it. Okay, so there it is. It's just a normal equation graphed with a whole at 2. And here's one more kind that you have to do. They'll give you a graph, and then you have to write the equation. I'll pause while you do it. Okay, so you start on that second one with y equals 2x minus 6 because that's the line without the hole. Then we have to add in the hole. Okay, so you just have to add that x minus 1 over x minus 1, which will cancel and make the hole. And that's all we have for you today.